Hi, this is Mrs. Slater, and the last section is all about solutions of equations. Your goal for all of these is to determine if you can get 0 equaling 0, meaning that x value is going to be a solution. So if I can plug 2 into this equation as like this, 2 squared plus 4 times 2 minus 12, and get a 0, then I know it's going to be a solution. And after looking at the information, you can see that I multiplied wrong. So that's going to be an 8, and that's going to be a 12, which ends up being 0 equaling 0. So we would say that 2 is a solution for x squared plus 4x minus 12. Now the other one is a different story. If we had 4 squared plus 4 times 4 minus 12 and set it equal to 0, then our calculations give us 16 plus 16 minus 12. And since we get 20 equals 0, which does not equal to each other, we would say that 4 is not a solution to x squared plus 4x minus 4, meaning that that is not an x value that works on that graph. Okay, on this one, now we're moving to complex numbers. If I take an 8i and plug it in everywhere I see an x, it would look like this. 8i squared plus 64 equals 0. So if I square both things inside, it's 64i squared. And I squared equals a negative 1, so that's just negative 64. And when I put the two together, I get 0. So that means that 8i is a solution. Let's try negative 8i. I'm going to replace that with x. And again, we're trying to figure out if it does equal to 0. Negative 8 squared is 64, because negative times a negative is a positive. And once again, it's looking just like the previous problem, because we have I squared. And after they cancel, we indeed get 0 equaling 0. So we would say that negative 8i is a solution. Okay, now this one can be a little more tricky just because there's more to plug in. But we have to plug the whole thing in, 1 minus I squared plus 2 times 1 minus I plus 1, and we're trying to figure out if it equals 0 or not. So, like it or not, we're going to have to do a little foiling because there are 2 of them. So I'm just going to write it off to the side. First, outside, inside, last. So you get a positive I squared. Now if we clean this up, it would be 1 minus 2i plus negative 1, and then the negative 1s will cancel out, giving us a negative 2i for that first spot. So let's go ahead and write in negative 2i to replace the binomial squared. Okay, now for the next one, if I distribute this, it would be 2 minus 2i. And then the plus 1 I'm going to bring down. Okay, looks like we have some like terms here. Negative 4i, also a like term would be plus 3. And that is set equal to 0. And because we do not have them equaling each other, then this would not be a solution of the x squared plus 2x plus 1. Okay, so that's finding solutions. Now we're going to reverse, and I'm going to give you the solutions, and you have to find the equation of it. So in order to do this, we're going to write out what they give you. X is going to equal 4, and x is going to equal 3. Well, we're going to set both of them equal to 0, because by doing this, it's creating the factors of our equation. So x minus 4 and x minus 3 are factors of the equation, and now all we have to do is FOIL. So we have x squared minus 3x minus 4x plus 12 for a final answer of x squared minus 7x minus 12. And that would be the equation or the polynomial for the problem. Okay, now we're dealing with imaginary numbers. So again, set them both equal to x, and then change that to where we're setting them both equal to 0. Okay, so we have just created our factors. And if you notice, those are conjugates of each other, so that will be nice because the outside and insides will cancel out because you have a positive 3ix and a negative 3ix gone. Negative 9i squared And so we have x squared plus 9 because we know I squared equals negative 1. And then that's going to be the equation where 3i and negative 3i are solutions. Okay, and that about does it. Thank you for listening. Then this concludes 710.